Hey, welcome to my channel. In this video, we're going to be looking at set theory, an essential topic for the Jamb exam. So, first off, we are looking at the definition of a set. This video is all about introduction to set, listing the elements of the set, determining the cardinality, and different types of sets and the associated symbols. So, first off, it says the collection of well-defined objects or things, a list of things, a group of objects that are actually related to one another, right? That's what it says. It's a collection of well-defined objects or things. So as you can see on the screen, different examples we're giving. We have a collection of books at a library, a set of mathematical instruments, a collection of artworks at a museum, a set of integers. Yeah. So this is what the set is all about. So one fact you should note about the set theory is that each member of the set is called an element. So if we have a set, maybe we have the book, the pen, the mathematical instruments, we have different stuff that have to do with stationaries, then each of those members, the pen, we call them elements, right? So another thing to note about this set theory is that if an element belongs to set X, then that means A, this symbol right here on the screen represents that it belongs to that set. It shows that A belongs to the set X. But if we should have A does not belong to X, that is what we are saying. Where this pointer is on, that's the symbol we use, is not a member of the set, right? So first off, I'm going to look at listing the elements of a set. I'm going to do that easily, right? So first set we have is X, where we have 1 less than X less than or equal to 9, given that X is an integer. So this is an inequality which we could break down in two ways, right? The first inequality we have is 1 less than X, right? And if 1 should be less than X, that implies that X is greater than 1. Let's say that X is 5. If you say 1 is less than 5, right, we could really say that 5 is greater than 1. So if 1 is less than X, that means X is greater than 1. And then the second part of it is that X is less than or equal to 9. So we are looking at numbers that are greater than 1 and are less than or equal to 9. And what are those numbers? 2, 3, 4, 5, 6, 7, 8, and 9, right? The second set we'll look at in this video is n. X2 less than or equal to X less than or equal to 10, where X is an even number. So you ask yourself, what's an even number? A number that divides 2, right, without any remainder. And within this this inequality, we have 2 less than or equal to X. This implies that X is greater than or equal to 2 and X is less than 10, right? So if you look at this boundary now, right, we have 2 is an even number, we have 4, we have 6, we have 8, and then 2, 4, 6, 8. This 10 is not meant to be here because we don't have any. This is less than 10, right? This is less than 10. So 2, 4, 6, 8. Those are the even numbers that lie between that, because 10, including 10, will be wrong because we are asked less than 10, right? So for the third example, we have X 2 less than X less than or equal to 11. Sorry, 2 less than X less than 11, where X is a prime number. And that implies that X is greater than 2 and X is less than 11, right? So we first of all ask, what is a prime number? A number that has two factors, which are 1 and itself. And within this boundary of numbers greater than 2 but less than 11, the only numbers that are prime within this boundary, they are 3, 5, and 7, right? Those are the prime numbers that lie between this finite set. Then the next question we have Q. X, where we have 3 less than or equal to X less than or equal to 15, where X is a composite number. So what's a composite number? Composite number is a number that has more than 2 factors. That means it doesn't just have 1 and itself as factors, it has more than those factors, right? For example, 3 is not a composite number because the only factors that 3 has is 1 and 3, right? So if you look at numbers that are greater than 3 for Q, greater than 3, less than or equal to, greater than or equal to 3, right? And they are less than or equal to 15 that are composite. We are going to start with 4. We are going to start with 4. right? Because if you look at 4, we have 1, 2, and 4 as they are. We have 1, 2, and 4 as the factors of 4, right? 1, 2, and 4. And then if you look at 6, the same thing. 6 has factors 1, 2, 3, and 6. So it has more than two factors than just 1 and itself, right? So we have others between this limit. We have 4, 6, 8, 9, 10, 12, 14, and 15. All these numbers are composite numbers that bear more than two factors other than 1 and themselves. Then next we are going to look at in this video is the types of sets. Before we continue, please, I encourage you to subscribe to this channel to get more content related to the Jamb tutorials, anything concerning math and exams. Also do well to like and share this video, and as well, so do well to comment to this video. So the first type of set we are looking at is the empty set or the null set, and this is a set which contains no elements, right? And there's a symbol that's used to represent this. You can see it on the screen. These are the two possible symbols we could use to see that this set is empty or no. There are no elements that are here. It's just an empty space, right? So what are the examples of such sets? Now we have D, where we have x2 less than x less than 10, where x is a negative integer. Now, if we should look at this inequality, 2 less than x less than 10, what does this imply? It implies that x is greater than 2, because if 2 should be less than x, that means x is greater than 2, and then from what we see on the other side, x is less than 10. So if you should list the elements of this set, we'll have 3, we'll have 4, we'll have 5, 6, 7, 8, and 9, which are not negative integers. So this set is empty because there is no member that lies between this limit, right, between this inequality that is going to satisfy the condition, which is x is a negative integer. So D is empty, right? Then E says states in Nigeria that begin with the letter X. There's no state in Nigeria that begins with the letter X, so that's an empty set. That's another example of an empty set. Then the second type of set we'll be looking at is a finite set. A set whose elements are countable, definite, or discrete. We've looked at examples like that, right? We can really define their contents, the contents of this set. We can really count them out. We could really state them out, right? They are definite, they are discrete. Now, example, we have Lx, where 0 is less than x, less than or equal to 15, and x is an odd integer. We could practically list out the elements of this set, right? Odd numbers, we have 1, we have 3, we have 5, we have 7, we have 9, we have 11, we have 13, and we have 15 itself. These numbers divide to with remainder, right? So we could actually list the elements of this set. The elements are countable, the elements are definite, the elements are discrete. And the second example we have is m equals x, 6 less than or equal to x less than or equal to 15, where x is prime. So what does this imply? That means that x is greater than or equal to 6, and x is what? Less than or equal to 19. So within this boundary, to check numbers that are prime, we can define them. We have 7 is prime, right? 7 is prime, right? We have other numbers. We have 11, we have 13, which are prime within this. We could actually list them out, right? But the opposite is what we have next, the infinite, a set whose elements or members cannot be counted. The endpoints of such sets really lead to positive infinity or negative infinity. That means sets that don't have an end. We can't really count the members. The cardinality of such sets are undefined. So an example is where we have x greater than or equal to 5, where x is an integer. There are millions of numbers that are greater than 5. This set is not countable, right? There is no inequality, there is no boundary for us to actually state the element out. So this such sets are not countable. As you can see on the screen, they cannot be counted. Another example, we have negative 3, negative 2, negative 1, 0, 1, 2, 3, down, right? It doesn't have an end. it will tend to positive infinity. If it's going in negative that direction, it will tend to the negative infinity. The next type of set we have is the universal set, and this represents the total collection of elements or the members that are being talked about. And then you should also note the symbol, right? This symbol or this symbol could be used to show that this is the universal set. This is the one that is that contains all the elements that we are actually talking about, right? If we should take a real life scenario, if you should look at the components of a math set, the components of a mathematical set, the universal set is the math set, right? Which contains all those books, pencil, pen, compass, protractors, and all of that. So if we should take out pencil, compass, and then ruler, we could actually say that those are subsets. So the main set, which contains everything we are actually talking about, is the universal set. The next type of set is the subset, which I just introduced. There are smaller sets which are members of a particular universal set, right? They are smaller sets. As I mentioned, you would have the pen, the ruler, and maybe the sharpener. Those are the subset. Those are the smaller sets that belong to the universal set, or maybe a larger set. So, example we have on the screen, we have a equal to 1, 2, 3, 4, 5, 6, and we have b equal to 2, 4, 5. So having this, looking at the two set elements, we could deduce that b is a subset of a, because the elements that are in b could be found in a. We could see 2 here, we could see 4, we could see 5, right? So b is a subset, and there's a symbol that is used to show that an element is a subset, that a set is a subset of a larger set, right? And that's simply this symbol you could see on the screen. If b is a subset of a, then b, this is the symbol. Else, if it's not a subset, we use this symbol right here where the pointer is not a subset of a. So you should understand the symbol and know how to interpret them, so that if you can see a symbol like this, you could actually deduce that they're trying to say that b is not a subset of a, or whether b is a subset of a, right? So next we are now going to look in this video is how to determine the cardinality of a set. It's a simple thing, right? Cardinality of a set is simply defined by getting the number of elements in a set without counting repeated elements twice. That's a key fact about it, and you should know the symbol that what is it denoted by, right? It's denoted by nx, where x is the set. So when determining the cardinality of a set, no element should be counted more than once. Repeated elements should be counted once, right? So we're going to look at examples. If you look at the first example, we have if b is equal to 1, 2, 3, 4, 5, then what is nb? It's simplified because if we count with our hands, we have 1, we have 2, we have 3, we have 5 elements that are in set b. So nb is simplified. But if you look at the second example, if we have c, we have 3, 7, 4, 4, 1, 2, 5, 6, 6. So if we start counting from our left, we'll have 1, we'll have 2, we'll have 3. We are not going to count the second 4, right? Because this is an element, so we don't have to repeat the counting. So we'll have 1, we have 2, we have 3. We skip this, we have 4, we have 5, we have 6, and then 7. We won't count the second 6. So that implies that NC is 7. And then if we have a set D, we have 2, 3, 6, 6, 7, 8, 9, 2, and we're asked for ND. Sorry for this error. We're asked for ND, right? If we should count, we have 1, 2, right? 3, we don't count the second 6. We have 4, we have 5, we have 6. We can't count the last 2 because we've already counted 2 before, right? So ND is equal to 6. Thanks for watching to this point. I encourage you once again, if you've not subscribed, to do well to subscribe to this channel for more interesting content related to this. Like and share this video, and also do well to comment. Thanks for watching.